Good morning, or as Isabella said, good evening. I'm really excited to be here. I hope that you guys enjoy this lesson today. Um, and it kind of inspires you, whether you come to Red Bank Catholic or not, but it inspires you to maybe take a look at possibly pursuing, something in the engineering field. So what I'm going to do right now is I'm going to present my screen. So some of you are probably saying, what is CAD? CAD, what does that even mean? So CAD's short for computer aided design. Back in the day, they used to sketch everything by hand. They used to draft everything by hands, but now we have programs out there, a lot of them actually, that will help us to design and make things in whether it's 2D, so something that's perfect in 2D, or actual 3D, so we can see it in 3 dimensions and actually turn and move and look at the part. So we can see the assembly below. Everyone knows what a quadcopter is. So that is actually a AutoCAD rendering of a quadcopter. So you can see that it kind of helps you to lay out all the parts, and you can actually build and assemble items like a quadcopter in the computer program by designing each individual part. So it's like a language. And like any other, thing that we do in the world, we have to learn the language in order to communicate. And CAD helps us to communicate ideas to the world. So we have something going on in our head and we have some idea, and it's really hard for me to explain an idea to you without sometimes showing you what it looks like. So that's what CAD helps us do. So that brings us to the next part. Who uses it then? Who uses AutoCAD to convey their messages? What kind of careers are out there? What can I do with this? So like I said, in engineering, AutoCAD is the first thing that you usually learn when you're a freshman in college. And so for mechanical engineers, you're usually in the top left corner. You're usually putting together mechanical parts. So this is an assembly of a bearing sleeve, right? So someone designed this assembly, and you can see that it's kind of pulled apart. And so that's the way that we can visualize what each piece is. So it's labeled. It says, it has all the parts labeled, it has the base labeled, it has everything labeled. So mechanical engineers, civil engineers, biomedical engineers, ones who, engineers who are designing things that, for pieces that go inside of your body, whether it's a fake shoulder, a fake, knee, they're designing it first on AutoCAD before they ever bring it into the real world. Now, on the bottom left, we see kind of this open layout of a house. So architecture is huge in AutoCAD. They never start building unless they have a plan. And that plan first comes from the architect. The architect designs it so that we can see it visually and aesthetically and see like, okay, I like the layout of this. And then from there, it gets put into a more detailed plan of, we send it off to the construction worker who then reads the plan to say, okay, I need to build this wall, and this wall. So it's super important. This is the foundation of every single project or every single product that's out there. It's first done in AutoCAD. So let's jump even to electrical. So the top right, I know it's kind of hard to kind of decipher what it is, but that is a picture of some electrical, panel that is laid out on AutoCAD, so they know exactly how they want to put their components in there and run the wires. So all those little, purple lines, orange and maroon, I think that is, all those lines are actually wires, so they know exactly how they want to run their wires and where they're going to place all their electrical components. And then the last one, last example on the bottom right, and not the last overall, but the last one that I put on here was that is actually a rendering of a ring. So jewelry is even a huge industry that uses AutoCAD. And for most of them, they're not engineers, they're just designers, and they learn AutoCAD so that they can design jewelry, because jewelry is very intricate. If you've ever seen anyone's like with diamonds and studs and all that stuff. There's very tiny parts to it. So the way they make it is they design it on here, they 3D print it, and then they cast it. That's the new method of creating jewelry. Back in the day, everything was done by hand. A lot of stuff was done by hand. But now with AutoCAD, we can automate also the production of it, which is where the 3D printing comes in, and lasering and CNC. And these are all the other different things that go along with AutoCAD that connects it to make parts. So let's take a look. Let's meet Robo Guys. This needs to be launched in 2021. So what we're going to do, and we're going to follow the engineering design process. So ask, identify the need and constraints. So he already gave us that this needs to be launched pretty quickly. So we need to prototype this pretty fast. We have the original unfinished product. And he also said that we needed to add something. We need to add a LED screen to the front. So let's keep that in mind. So let's jump to the research part together. All right. So what I'm going to do right now is we're going to take a look. I'm going to switch my screen over so that you can see what I'm doing. So I'm going to get it out of present mode, and we're going to put together kind of a better picture of who this guy is and the measurements of him. So I have some of the measurements put together. So we're going to break it down piece by piece, and we're going to kind of get a better idea of exactly what this guy is in terms of all of his measurements and everything like that, so that we can take it and put it into AutoCAD and then fix it up and put whatever we need to onto him or modify him the way we see fit. So let's do that now. Okay, so here's Mr. Robo Guy. What I have here is a caliper, so this will help me take measurements. Now I have some of the measurements, but I just wanted to show you what we do. So if I want to take a measurement of the head, I'll put it like this, and I'm reading in millimeters. So right now it's reading 19 millimeters. So what we're going to do is we're going to create a profile of the robot. So what I want to do is I want to kind of break it down into its main components. So we have a few different main components. We have his head, which includes his antenna, his eyes, his mouth, and we'll even say his neck, right? So his neck part. Then you have his main body, 2 legs, and his feet. So what we're going to do is we're going to write down all the measurements, and we're going to kind of put them together so that we can take all of those measurements and transfer it over to the CAD software, which is SolidWorks. So his head looks pretty cubic, so we're going to draw his head first. So we're going to write down head. And we're going to sketch a cube. Okay. So, like I said, it was 19 millimeters. And when I took the measurements of the other side, so I took this way, and this way. Everything is 19. So we're going to have 19 millimeters by 19 millimeters. By 19 millimeters. This is our SolidWorks. This is the program that you'll be at the end of my class, you'll be able to use this like any other video game, right? I know all of you probably play video games. All of my kids play video games. This is just like a video game for adults who are creating things. This is like Minecraft. I have some kids in my class who are like, can we make this in Minecraft? I was like, yeah, you can, but you can make something real in this one and actually print it. So let's start, right? So just like we did, just like we saw 2 seconds ago, we're going to pick a plane. So the first plane I'm going to pick is the front plane, and we're going to start with the body of the robot. It's the biggest part, and I think if we start from the body, we can go up, do the head, and we can go down and do the legs. And I'm going to show you, you know, as we go through this, I'm going to show you all the little, you know, things that I do and what everything means. So as I was saying, the word that I keep mentioning is sketch. So right up here in the top, we have sketch. So I'm going to click and I'm going to hit here to create a new sketch. And automatically the program says, all right, where are you going to sketch? Because you have to sketch somewhere. We're going to sketch on the front plane. All right. So the body of the robot is, if we look at the front, it's a square. It's 25 by 25. So here are all of our you know, our shapes. And it's kind of like if you ever used Google, you know, Google Docs or Google Slides or Microsoft Word. If you create shapes in there, it's the exact same way. So you're going to look for the shape that you want, select it, and then put it on the screen. Now, this is a little bit more specific because it wants to know exactly where you want to place it. So we'll see that. So we're going to click a corner rectangle. We're going to hover over the center here. This is what we call our origin. So in math, right, we have the origin, the 0, 0 spot. That's the 0, 0 spot of our entire sketch area. So we're going to click once, click twice. And now we have a rectangle in the middle of our graphic area, right? So the graphic area is just where we're making our sketch here. So now we're going to smart dimension. This is where we put in the dimensions that we found before. So this is going to be, oops. And I forgot to mention, we were working in millimeters, so we need to change our units over to millimeters. There we go. So it was 25 millimeters. We're going to sketch that in that sketch. Now, this is the interesting part. I have a circle within a circle, so when it extrudes it, so let's make that 2. It's great to make a design, but it's also another thing to make a design and know how much it's going to cost. So you can notice that, you know, this is the same size as we built it. So we built it, you know, specifically to be this size. When we go to hit prepare print, the program tells us a lot of the information. So it says the build time is 1 hour and 12 minutes. Well, that's not going to work for us unless you want to stay here later. And the cost of the material is only 58 cents. So this little guy will cost us 58 cents. It tells us the plastic weight, how much plastic it's gonna need, and the filament length. So we'll get to what that means, the filament length, because the way that the 3D printer works, you'll understand that it has a length that it needs of material. So it takes like a string, melts it, and creates the part. This is what it's going to look like. You can see all of the detail of where it's going to lay plastic down. It lays it down like, if anyone has ever used a hot glue gun, it lays it down. And I'm going to show you, you know, virtually here. So this piece, this piece right here, that's where the molten plastic is coming out. It's like oozing out, right, out of like this needle-like head. And it's laying down all these different layers. All those different lines is where that head goes over and runs over with the hot plastic. So we're going to jump over. I'm going to stop here. We're going to jump over and look at the 3D printer and get this thing started here. So this is our 3D printer. So I'm going to jump here. I'm going to hit play. And scroll down. Robo guy. So again, we got a couple minutes here. So again, what's going to happen here is this piece here is the hot end. That was that needle. And you can see that there's this kind of wire going to it. Inside that wire is plastic, which is seen right here. So this is the plastic, and there's a reel up on top. So that plastic is on a reel, and it goes down, and then it gets put in and pushed through the top of the hot end. so now it's laying down the first layer of RoboGuide. Now we got our first layer down of RoboGuide. All right, so now what you see it doing is actually laying the top layer of the head on there. So remember that the face is solid. So right now it's printing it, it was printing it hollow. So now it's filling in the top so that it has a top layer. So we'll do it again, you'll see it zigzag. We're at 85%. I'm sorry for you guys who are tired or want to go play your video games, but all right, so now you can see it making the eyes and the mouth. So here we go. Robot number 2. We didn't put the arms on because we ran out of time, but we got our prototypes here. So we're ready for got a little robot family now.